Hello and welcome to the Connected Media IP Panel Debate Theatre here at NAB Show 2022. Thank you all for joining us, and it is wonderful to be back to such a lovely, spacious, airy venue. So that's it, we're kicking off now, 3 days of panels and debates on this theatre and on the one just further down the way. And it is my absolute pleasure to welcome our opening session for the year. Gordon Brooks, CEO of Zixi, to talk about the journey to autonomous broadcasting. Let's welcome him with a round of applause.
Thank you. Thank you. Good morning. Back at NAB. It's exciting. Exciting. So what I want to talk about today is the journey to autonomous broadcast operations. There's a lot of things that are driving this move to being more autonomous, which is taking the guesswork out of how we run our broadcast operations. Things like mergers and acquisitions are happening, market dynamics are changing, we're trying to scale production without scaling operations, we're trying to do more with less, we're trying to increase our operational agility, support international audiences, increase live engagement. So there's a lot of things that are going on that require this move to autonomous operations. And it's not a new journey. So if you look at the airline industry or how commercial flights are done, they're all flown autonomously. Air traffic control is autonomous. And I don't think what we're doing is more difficult than that. I think it's doable. If you look at what's going on in energy, so you look at major power plants, you look at electric grids, those are all autonomous. You look at what's going on with the automobiles, that's on the journey to autonomous, and we're on that journey too. And where does auto start? It starts with front cameras, rear cameras, lane assist, auto braking, all sorts of different features that eventually get you the collective so that you can operate these vehicles autonomously. So data is key to all this. It's the oil of the information age, and machine learning is really the engine, and democratizing that data science is key to autonomous broadcast operations. Today, for our customers, we're doing advanced analytics, ML, AI on over 9 billion telemetry data points every day. So that's just a lot of data that humans cannot shift through if they tried, and certainly not make sense of. So where are we headed with AI and ML in operations? Well, one is visualizing this massive amounts of data. So if you've got literally hundreds and hundreds of telemetry data points across your network, on the edge, in the cloud, and you're polling that every 5 seconds, you imagine how much data that is to analyze. And so being able to put all that together and show you areas where you need to take actionable insight is part of this drive to autonomy. Making self-optimizing workflows. We operate with things like blast radiuses and things like that allow you to architect your networks and your workflows so that you have minimal damage if you do have particular issues. And then one of the big things out there is root cause analysis and automating that root cause analysis. The estimates I hear, and I don't know if you guys agree with this, but an average broadcast channel spends about $500,000 a year on root cause analysis. It's all those meetings with 25 people and 4 vendors trying to point fingers at each other for 2 weeks to try and figure out what's going on. What we're talking about is if there is an incident, then to capture all the logs, all the graphs, and be able to have the system say this was the problem and here's the remedy, and be able to document that for you. So what are we talking about when Zixi talks about AI/ML? Well, this is really kind of the media supply chain, and inside that blue box in the middle is really what we're talking about. We're really talking about post-production all the way through to content distribution. So we're not talking about face recognition or some of the other components, not that those aren't valid use cases, it's just not really what we're focused on. So here's how I think it can help, and it is a hierarchy of value in AI/ML. So for a long time with our Zen Master, we've been collecting the data, putting it in a canonical form that can be understood, real-time or near real-time processing, providing feedback loops, data repository, visualization. But you really need to get to more descriptive. So there's an anomaly. What is the anomaly, and what should I do about it? And then predictive. So is there a problem? Do we think there's going to be a problem before that problem happens, so you have a chance to fix it? And then prescriptive. How do I fix it? And then continuous learning, so that you're continuously learning from all this analytics that you're doing every day. So these are two ways to look at anomaly detection. There's one anomaly detection model. It's not particularly useful, right? One is two-dimensional. This is 20 sources of Zixi content, right? You can see anomalies there. The pink is anomalous, the longer it is, but it doesn't really give you a whole lot of value. On the bottom is 2,000 sources. That's a little bit more helpful. It's multi-dimensional. You can see where there might be problems, but that's not terribly useful for an operator or even for a video engineer. What we're doing is our models are operating in 50 dimensions. And we use 3 different types of anomaly detection models and 2 different types of classifier models to predict video degradation before it happens. Some of the constraints is that, for autonomous operations, is everything's very noisy. All the alerting, you got all this data and all these things you can alert with, but there's so much of it, there's too much of it. And right, so you see people muting a lot of the alerts out there just because they can't process it. It's overloaded. There's poor visualization. There's no really good way to look at it where a human can look at it and say, there's a problem, or there's a answer to the problem. So how do you visualize it? And you're visualizing large amounts of data, which is complex. It's not something you can typically do in a traditional database. And that we're fixing problems after they happen as opposed to trying to fix them before they happen. We talked about the root cause analysis. It's a costly process and really prone to not necessarily finding out what the true problem was or fixing it. And then you need agility. So the more analytics you have, the more confidence you have in your solution, and the quicker you can deploy. So what are we doing to give you greater autonomous operations? Well, one is the telemetry data, providing more telemetry more often. Like I said, 9 billion data points a day for our customers. So that's just a lot of data that we're helping our customers analyze. We're using AI and ML to predict encoder quality without seeing source. We're using it to predict anomalies, not anomalies, but video degradation before it happens. We're using it to filter out the noise. We're using it to provide insights and answers. And we're using it to leverage the identity of outliers, so it's really clear what issues you might be looking at. You're looking at to be predictive, to predict what will happen. We're looking at it to self-optimize, to learn as it continuously operates, and to do rapid incident response. So that's what we're doing today. There's a whole lot of things that we're going to do, but this is a journey. That's why the title of this is The Journey to Autonomous Operations. We're not there yet. Self-driving cars aren't quite there yet, but over the next year or two, we believe we can get there. And our customers so far believe that as well. So I talked about using 5 continuously updated machine learning models trained on over 90 billion telemetry data points. So we initially train on 90 billion, and then we continuously train. Access to real-time and historical data, and to be able to combine that. And to do AI and ML on time series data is a complicated thing. Not a lot of solutions can do that. So we're geared to do that on time series data, which obviously we need to do. And then anomaly detection. So this is Zen Master. Everything in our intelligent data platform is displayed through Zen Master. Zen Master is our control plane, our orchestration. It's how you set things up. It's how you monitor. It's how you manage. It's how you deploy. It's how you fix problems. It's how you get into your edge devices, all from a single control plane. This one is just showing, there's a better one a little bit later, but it's showing a diagram of the channel workflow, and then it's showing a health score that goes down, and showing that you've got TR101 errors and other errors to be able to then pin to a particular problem and identify it and then fix that problem. This one happens to be a transport network issue. Then you can say, okay, if you're predicting that it's going to go down, that the video degradation is going to have an issue, my overall health score is an issue, why? And so it'll take the top 5 things that the models are understanding and learning, and will tell you what they are. The first one here happens to be decrease in latency to configuration ratio. So there's this happens to be an analytic, and it's finding that that is the biggest thing that it's seeing for the particular issue at hand. But it identifies why, and then it enables you to go and say, okay, why did that happen? Why is it thinking that? And then fix that particular problem. Okay, I do think the idea of faster, cheaper RCA is key. I talked about the $500,000 spend per broadcast channel. What if I could save 10% of that? What if I could save 20%? What if I could save 50%? What if I could save 80% of that? Right? There's a real payback there. There's inefficient communications across siloed and external operational groups. So this all has a collaborative component to it, so that you can share all the information, all the analytics, all the graphs, all the logs, time synced with groups, and collaborate on it between operations and engineering and others that need to understand it. You can look, by the way, you're typically working across myriad types of networks. Our customers are using fiber and 5G and 4G and internet, and sometimes intermixing. The ability to identify those networks and identify network issues that might impact a number of your different workflows is really key. Accuracy, speed, and then being able to do that single source of reporting. And then, and again, it's all about the data visualization, the data collection, and then generating and sharing those particular reports. So this is what we call the insights view, and it's a way to look across your entire organization. This one happens to be a very noisy one on purpose, but on the top you'll see those balls. Those are video degradation issues, and how long they are is how far they are on the bottom axis, and how severe they are is how far they are on the left axis. Typically you'll see a blank screen if you're not having any issues, or you might see 1 or 2 sources or 1 or 2 targets. This one is in a demo environment, so it's showing a whole cluster of experiencing high error rates. On the bottom says, okay, I want to look at, and the system will say, we think you have broadcaster issues, which is our main software component. And so let me look at all my broadcasters and look at all my broadcasters compared to each other. And on the bottom, what you're seeing is all your broadcasters, and we happen to have multiple KPIs you can look at. This one happens to say, look at CPU, and you'll see that cluster is associated with CPUs that are running over 80% memory, which we recommend you never be over 50%. And you'll see most of the broadcasters for this group are under 50%. So just that's something I'm going to have to go deal with, or I could potentially have a more serious problem. This is what an RCA looks like. It'll show you the diagram. It'll show you where errors occurred and what level those errors are. And then you can pick whatever graphs, whatever logs. Those white bars, you can lock them in, unlock them, go to different parts of your workflow, bring in different logs, different charts, and then collaborate on that for ultimate determination of what the root cause is. So key takeaways, this is not new, right? I mean, autonomous is going on all around us in very, very complicated areas like aviation, but nobody's really done it for broadcast operations yet. And we think everybody's going to need to do it. Historically, our industry has been siloed, and with limited fixed infrastructure, that lack access to full supply chain data. So it's giving that visibility across the different groups, even as our clients are becoming less siloed, especially with the move to the cloud, but that's still an issue. It's all software defined, so there's no physical or hardware components that are required in this. It's increasing complexity with IP networks. We're doing a lot with 5G with AWS and Verizon and Bloomberg, doing satellite replacement. It's a combination of 5G with backup of 4G LTE with some fiber and some internet until 5G gets to all the different locations. But those networks are actually even more complicated and a little bit more messy. And with the right architecture and data, it's available today, and the payback can be really exponential, because what's the cost of a failure? It's very, very large. And the ability to be proactive and be predictive and to make sure your problems are taken care of before they become real issues. And with that, I will pause, and if there's any questions, I'd be happy to answer them. No questions? Okay, well, thank you very much. Appreciate your time.